Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to continue with matrices, and we're going to talk about determinants of matrices. Determinants are very useful for a few things. First of all, in programming, they're very useful. But secondly, mathematics related, you can find the area of a triangle using matrices. You can solve systems of linear equations, both if you have two terms, two variables, or three, using something called Cramer's rule, which uses determinants. And you can find inverse matrices by using determinants. So determinants are very useful. We are going to learn today how to find determinants of 2 by 2s and 3 by 3s. And then we're going to learn how to apply determinants to solve systems of linear equations with both 2 and 3 variables. Okay, so again, determinants are very specific matrix values calculated through a specific formula. Determinants are used to find inverses and the area of any triangle. So I'm repeating myself. We're going to learn today 2 by 2s and 3 by 3s. So let's get right to it. Okay, the formula for a 2 by 2 matrix determinant is literally, as you see here, A times D minus C times B. Literally. That's it. That's the determinant. So for example, if I have a matrix that's 2, 5, 7, 9, my determinant, which we'll call capital D, will equal 2 times 9, which is 18, minus 7 times 5, which is 35. So my determinant would be negative 17. Nice and simple. Finding determinants of 2 by 2s, as you can see, are very simple. Okay, very, very simple. Now, to find determinants of 3 by 3 matrices, it's still simple, guys. I promise you it is. Just a little bit more complicated, okay? They'll give you this 3 by 3. To find the determinant, you can use a method that's similar to the 2 by 2, but it's just crazy town. It just gets crazy. I mean, crazy. Or you could use a little trick that I came up with. When you have this matrix here, 3 by 3, go ahead and rewrite it. And then add the first 2 columns right next to it. Don't include it into the matrix. Just write the first 2 columns right next to the 3 by 3 matrix. Then I'm going to find 2 sums. Okay? So you can see the red and the blue arrows here. I'm going to first find from this bottom left-hand corner. I'm literally going to go up and multiply everything here. So I have A3, B2 times C1 plus my next term all the way across, which is B3, C2, A1, plus my third term. I'm going to multiply all the way across, which is my C3, A2, B1. Okay? Then I'm going to go to the top left-hand corner, and I'm going to go down diagonally, giving me the product of A1, B2, C3. Then I go to my next column, multiply all the way down, giving me B1, C2 times A3. Then I go to my third column, and I multiply diagonally all the way down, and I get C1, A2 times B3. And in the end, I'm going to find my determinant here of a 3 by 3 by taking the sum of the red values, which are right here. So I'm just going to go sum of red minus my sum of blue. Literally. And that's it. So here, what do you have to be aware of? Well, first of all, you got to make sure that you line things up neatly. I know how some of you write, and sometimes you jumble things up. I'm telling you right now, my brothers, no offense, if you jumble things up, you're going to get it wrong every single time. Be neat about this. And then secondly, you got to know how to multiply. Okay, I'm not being sarcastic. A negative will mess up the whole entire answer. Okay? So that's how you find these determinants. So let's do a little practice. Okay, find the determinant of each matrix below. Give you a little hint there. Remember, it's just the product of the first and the fourth term and minus the second and the third term. Yes, sir. Yeah, this is going to be this is going to be 15. Yeah, minus a negative 2. You're absolutely right, 17. Perfect. That's it. It's that simple. Determinants of 2 by 2s are a joke. Does that make sense, boys? Simple, right? Nice and simple. Okay. Now, determinants of a 3 by 3. Okay. Remember, see how nice I am? Remember to add those first two columns to the right of the matrix and then follow my diagonal sums. So I'm going to do this in the correct color so everyone's happy. Let me go through it first, Papa. Try to do it on your own, though. So remember, I'm going to take these first two. I'm going to put them over here. Very neatly, though. Aligned perfectly. Okay? I'm not trying to be sarcastic. But I know some of you. And you're going to like jumble it up. You're going to be like, Morrible, what did I do wrong? You're not trying to give me art. You're trying to be precise. So now, let's do our reds first. We're going to go ahead and find the product of the sum of all of that. So, or the product of that, I'm sorry. What's 1 times 4 times 2? 8. Plus, what's 0 times negative 1 times 3? Plus, what's negative 2 times 0 times 5? 0. So my sum of my reds is right here, 8. Is everyone here with me? Yes. Minus, now let's go sum of blues. Bottom left-hand corner. What's 3 times 4 times negative 2? Negative 24. Plus, what's 5 times negative 1 times 1? And what's 2 times 0 times 0? So negative 24 plus negative 25 is minus, it's a negative 29. So I'm going to put in parentheses negative 29. And I told you to find the determinant here. It's the red sum, or the bottom sum rather, however you want to see it, minus the top sum, or the blue sum. So 8 minus a negative 29 will be nice and easy, 37. And that's my determinant. Literally, that's it. Does that make sense, gentlemen? May I continue, gentlemen? Thank you, brothers. Okay, so, all right, this time no hints. Okay, what's my determinant here, Papa? What's my determinant, Papa? Okay, good job. 15 minus 12, which equals 3. Good job. Now, how about B? Yes, sir, my brother. It would be 0. Negative 2 times 0 is 0, minus 3 times 0, which is 0. So my determinant is 0. Very good. Okay, talk to me.
Okay, so you would add the first column.
Very good. You add the first two columns. Good job, my brother. Please, guys, try to be as neat as possible. Please, okay?
So the bottom 60.
Hold on. So I've got 5 times 4 times 3 is 60. Good.
Negative 1 times 6 is 1 is +6.
Times -6. I'm plus -6. Come on, Moro.
And 0.
Plus 0. Excellent, son. Excellent. And my red, quote unquote, on my bottom one.
12.
So this is 1 times 4 times 3, which is 12. Good job, my brother. Good job. Excelente. Okay. So then what would my determinant equal, my brother?
-48.
Okay, this is going to be 12 plus a -6, so that's 6 minus 54, which equals -48. Excellent. Good job. Excellent. Does that make sense, gentlemen? Promise? Any questions on determinants, my brothers? Okay. These are some practice problems. The top one, as you can see, is a 2 by 2. Easy. And the bottom one is the scan or the barcode for 3 by 3s. Okay? All right. Thank you very much. Hope you learned a lot and have a great day.